Hello everyone. The topic for today's lecture is files and directories. We deal with files and directories all the time while working on our laptops or desktops. Recall that we have already covered Python code snippets which enable us to process files. When we covered the topic of CSV, we started using the process underscore CSV function to parse a CSV file's contents into a list of list data structure within Python program. When we covered the topic of JSON, we learned how to use the read underscore JSON function to parse a JSON file's contents into an appropriate data structure within Python. Recall that we have used write underscore JSON function to write a dictionary data structure's contents into a JSON file format. In today's lecture, we are going to learn more about reading and writing files. Let me get started by doing a quick recap of a couple of concepts that we covered in the previous two lectures. Recall that file objects are of type iterator. We are going to use this concept extensively as part of today's lecture. Last lecture, we learned all about exceptions. Exceptions can occur all the time while dealing with files and directories. Some of the exception examples that I covered in the previous lecture could be handled very easily within the Python program. Let me give you an example. Let's say that we want to avoid zero division error. It is very easy for us to write an if condition that is going to check whether the denominator variable value is greater than 0 before we actually proceed with the division operation. That will ensure that we don't run into zero division error. The exceptions associated with file or directory processing, on the other hand, are going to be tricky to handle within the Python program. Let me give you an example. Let's say that you're trying to write a program to create a brand new file. While executing your program, you run out of hard disk space, and that's going to throw insufficient disk space exception. You might be wondering, can't we write an if condition to check whether there is sufficient hard disk space before we proceed with the file creation line? That might or might not work depending on how many other programs or applications are concurrently running on your laptop when you're trying to run your program. Between the lines of code which are checking for sufficient hard disk space and which are creating the brand new file, some other program could scoop in and take the available hard disk space. So you're still going to run into the insufficient hard disk space exception. The best way for us to deal with exceptions when it comes to file and directory processing would be to use try except blocks. Let me outline the learning objectives for today's lecture. We are going to learn about the open and close function calls, which will enable us to process files. We are going to learn how to read data from and write data to a file. Following that, we are going to cover various functions associated with OS module. The join function, which is part of the OS module, enables us to write portable code. What exactly is portable code? When you write a program in a specific operating system, say Windows, and you're able to take your program and run it on a different operating system like Mac or Linux, then your code is considered as portable. Following that, we are going to learn how to deal with exceptions with respect to file or directory processing. Finally, we'll be covering a tricky but important topic of encoding. Let's get started by learning about the built-in function open. Recall that open takes as argument the relative path to a file and returns a value which is going to be the file object reference. You need to always make sure to use relative path to ensure that your code is portable and you can take your code and run it on some other laptop. Let's consider that all of these lines of code are within a script file called main.py, which is within a directory called demo. The demo directory also contains file.txt and data subdirectory. The relative path to file.txt is simply going to be string file.txt. because both main.py and file.txt are in the same directory. The relative path to movies.csv file inside data subdirectory would be data/movies.csv. Quick quiz question. Am I writing this relative path on Windows or Mac or Linux laptop? If you were thinking Mac or Linux laptop, then you had the correct answer to my question. That's because I'm using forward slash as a separator between parts of my relative path here. Of course, this particular open function call is not an example of portable code. If I take this particular line of code and try to run it on a Windows laptop, it's not going to work because Windows laptop would expect us to use a backward slash. Relative path to a file A inside the snapshots subdirectory would be data/snapshots/A. Let's talk about using a file. With the file object, we can either read data from the file or write data to the file. The last operation that we are going to discuss here is the close function call, which is going to enable us to perform cleanup here. It is very critical for you to ensure that you invoke the close function call, which is going to pair up with the corresponding open function call. You're going to use the syntax as file object reference variable, which is f in this particular case, then a dot, then you're going to mention the function name of close, open parenthesis and close parenthesis. Let me give you a twofold reason as to why you need to always invoke the close function call. The first reason is because that will ensure that you're avoiding any data loss. Let's say that in the middle of your program crashes and half of your file's contents are still in RAM and not yet written to the hard disk, then you're going to end up losing all of those contents within the RAM. The second reason for ensuring that you're using the close function call is because you're only allowed to have limited number of open files within a program. You can imagine all of these steps to be part of a specific protocol. Whenever you're dealing with a protocol, you have to follow the provided steps exactly in the provided order. It can be thought of to be similar to a sandwich. The open function call is going to be the upper bread here. The file processing part is going to be the lettuce in the middle, and the close function call is going to be the bread at the bottom. Let's talk about reading data from a file. Let's say that file.txt contains three lines. First line is I promise, second line is to always, third line is close my files. There are a couple of ways for us to read the content within file.txt. Option 1 would be to use read function call. We are going to specify the variable which stores the file object reference, which is f here, followed by which you'll mention a dot. Then you're going to say read open parenthesis, close parenthesis. The return value is getting captured into a variable called data, and you're going to get a string into the data variable, which is the entire file's contents. Observe that each line is being separated by slash n within the string over here. Let's talk about the second option. Recall that file objects are iterators. Let's go back to this diagram that we discussed as part of the iterators lecture. Recall that there are a couple of things which you can do with an iterator. Iterators are iterable, so you're able to use the iterator within a for loop. Because of that reason, you can use the file object within the for loop. With iterators, you can also call the next function call to get the next item from the set of items within that particular iterable that is associated with the iterator. Recall that we can also convert an iterable into a list. Since iterators are iterable, you'll be able to convert the iterator into a list here. Let me cover examples for all of these. The first example that I want to go through is the for loop example. We are using the open function call to get the file object reference into the variable f. Then we can say for line in f. Line here is going to be denoted by the L variable here. Why does this work? That's because file object is an iterator and iterators are iterable. Let's look at an example of the next function call. With f, you can invoke the next function call, and that's going to get you the very first line of the file alone. The for loop ensures that you're able to iterate over all the possible lines. If you want to use the next function call, you'll have to make multiple function calls to get all of the lines out. The best use case scenario for using next function call would be when you want to just take the initial lines within the file and do some processing with it. Let's say that you're only interested in processing the header from a CSV file. The next function call will be very handy for that. The last example that I want to cover here is to use the list function call to convert the type of file object here into list type. So when you say list of f, that's going to give you a list of lines here, which is going to go into the variable lines. Let's talk about how to write data to a file. For reading from a file, we only dealt with a single argument, which is going to be the relative path to that particular file. In order to write contents into a file, we'll have to pass another argument which is going to represent the mode that we want to use the open function call for. W is going to be the write mode for writing contents into a file. R is going to be the mode for reading contents from a file. R is the default value for this particular parameter, so we don't have to specify the mode as string R explicitly when we want to read contents from a particular file. There are other examples of modes like append and other cases. For the purpose of CS220 or CS319, you're only expected to know about write and read modes. You can explore the other modes if you're interested, but you will not be tested on it. One of the key things for you to remember with respect to writing files is that whenever you invoke the open function call with W mode, you have to be very, very careful because that will override the contents of the existing file. Observe that previously file.txt had some contents. Since I'm opening it with write mode, all of the contents will get erased and we are going to work with a brand new file. What is the function which enables us to write content? That's going to be write, which is the opposite of the read function. The write function is going to take as argument a string value which is going to get written into that particular file. You will be able to pass a variable which contains a non-string data type directly to write, provided you don't concatenate it with another string. You're going to invoke the write command by using the file object reference variable, which is f here. Then once again, you're going to say dot write, and within the write function call parenthesis, we are mentioning the string hello, and then in the next write function call, we are mentioning the string space world and /n. You can either use a single write function call by concatenating all of the contents into one big string, or you can use multiple write function calls. With the same file object f, if you invoke the write function call multiple times, the second function call is going to append the contents to the previously written contents to the file, and it's not going to erase that particular content. So you're going to end up with hello world new line so far, and you're going to add all the exclamation points in the second line within your file here. When it comes to file writing, you have to keep in your mind that If you want a new line, you'll have to explicitly include /n as part of the string that you're passing as argument to the write function call. This is the most common mistake that I always keep making with Python programming. Why do we tend to forget the requirement for the /n? That's because all of us are very much used to using print function call all the time. Recall that the default value for the end parameter for a print function call is going to be the new line. Unless you override the end parameter's argument, you're going to always get a new line when you invoke the print function call. We are all used to getting new line after a print function call that we tend to forget that we have to explicitly add a /n while trying to invoke the write function call. I'll wrap up this video here. In the next video, we are going to start discussing about the OS module functions.